So in the last quiz, you have seen that it's not very likely that we can find a randomized algorithm for an NP-complete problem that in polynomial time will deliver us the right answer with a fixed probability. To be honest, we currently don't know if such an algorithm is possible or impossible, but many believe that it is highly unlikely, and so far no such algorithm has been discovered. It seems that we can sometimes, however, if we either cross this one here off our list or cross this one here off our list, and you'll soon see that actually it doesn't really matter what we cross off our list, but if we kind of reduce the number of wishes that we have, it seems that sometimes we can use randomness to at least improve the running time of exponential time algorithms. So just as you've seen when we optimized search trees, it's sometimes also possible to improve the running time of exponential time algorithms, or the base of the exponent, using randomness. Now the question, of course, is could we use randomness to help Alice solve vertex cover, or help Bob solve his click problem, or Carol her independent set problem, or Dave his shortest tour problem, at least when we say that we do not have this requirement here. And the answer, unfortunately, is we don't know. We don't know if there are good randomized algorithms to solve vertex cover, or click, or independent set, or shortest tour, at least not if we're demanding guarantees. So of course there are randomized algorithms that will look through a random number of solutions, and these are also used in practice, but again they do not offer any guarantees. There's one problem, however, that is NP-complete, where I can give you a randomized algorithm that at least is better than the best known deterministic algorithm, and that problem is 3-SAT. As I hope you will remember, the 3-SAT problem had as an input a Boolean formula with n variables. And the Boolean formula has a special property because it's 3-SAT, namely that each clause has exactly 3 variables. And the output I'm looking for is, of course, an answer to the question, if this Boolean formula with n variables, where each clause has exactly 3 variables, has a satisfying assignment. So how can you use randomness to solve this problem? Well, there's a very simple and in my mind very elegant algorithm that in 1999 was proposed by Uwe Schöning to solve a 3-SAT instance with n variables. So this is the algorithm, and as you can see it's really quite simple. So you start out by picking a random 0-1 assignment for the variables, and then you go into a loop that iterates 3n times, where n is the number of variables. And what you do each time in the loop, you take one of the clauses that is not satisfied, and then you randomly flip one of the variables of that clause. So what does this randomly flipping mean? You start out with a clause, and we already know that this clause will have only 3 variables, because we're dealing with 3-SAT. Now you randomly pick one of those variables, say we randomly pick the second one, and then you just flip its value, meaning if it was assigned to true, you now assign it to false, or vice versa, if it was assigned to false, you now set it to true. And since it's a random process, we don't know which variable we're going to pick. So instead of this one here, we might also have picked this one here, and of course this one here. And what happens is, by this flipping, you satisfy this clause, but of course other clauses might then become unsatisfied. Now, if we run this algorithm here once, what are the chances that it will succeed and find a satisfying assignment, provided that the initial Boolean formula does indeed have a satisfying assignment? If it doesn't have a satisfying assignment, the algorithm can't find it. But let's assume that it has one. Then the success of this algorithm will depend on 2 things. The first one is how far the initial assignment is off the satisfying assignment. Or in other words, picking this random 0-1 assignment to the variables, how many of those variables did we get right? And by right, I mean that we set them to the same value that they would have in a satisfying assignment. And the second one is, of course, are these random choices that we make here by flipping the variables successful? So if we are somewhere near a satisfying assignment, and by chance the algorithm makes the right choices, then we would find a satisfying assignment, provided of course, but we made that assumption, that the Boolean formula here actually has a satisfying assignment. But let's look at those 2 success factors a little more closely.